Deine Sterne, die strahlen mir auf fernen Ohr. Was sie sagen, wollte ich ja so gerne, als der Liebe zärtliches Rosenstrauch.
To this point, I've shared with you the steps that I used to pre-process all of my images. So we wound up with a drizzled master light frame, and if we had our other color data, we would have a master light frame for each of the broadband or narrowband colored images as well. But I'm going to continue forward looking only at the luminance processing workflow. So for the master light frame, our next step would be to carry out a crop of the image using the dynamic crop module. When we do this crop, we're going to save the crop coordinates so that they can be applied similarly to all of the other images that we've generated, regardless of the color. And this will make color combination much easier later on. So I've launched PixInsight and opened up the project file that I have for the Rosette Nebula. You can see here all of these stored modules that I used for my pre-processing. So we'll continue on where we left off. So first thing I want to do is open up the final integrated light frame that we worked on in pre-processing. So I'm going to say File, Open, and there it is, Luminance Drizzle Raw, and we can open that up. And I'm just going to expand it. So I'll tell you, honestly, I am not happy with this image. It has a lot of artifacts in here that I don't want to have in my final image. And I'm probably going to go back and reaccumulate this data, but perhaps it's a good image to illustrate how we can use our crop tool. So the issue I have are not in the flat framing of the image. It's actually quite good. You can see there's a little bit of artifact in the corner, but not much. But I do have these two very large reflections that probably came from lights in the bedroom window of the house or something. And I'd like to remove those from the field of view. So to do that, I'm going to go to Process, and under Geometry, we find the Dynamic Crop tool. So we open that up. And first thing we want to do is set a working frame. So to do that, we left click with the mouse, hold it down, and just drag. And we'll get a frame with a little X in it, which I'm going to center around the Rosette Nebula. And now we can orient this. So I would like to orient it so that the corner is tangent to this outer reflection. So if we go over here to the rotation section of the dynamic crop module and grab this little white box, we can rotate it to whatever angle we would like. So I'm roughly going to make it tangent. And then I can go down to the edge of the selection field and just drag it out to the edge of those reflections. So that's really nice. I can fiddle with this a little bit more to see if I can improve the orientation somewhat. So now what I'm going to do is drag the opposite side to keep the center of the nebula centered. And at this point, it becomes more of a question of aesthetics. And I'd like to make this frame as large as possible. So what I can do is now grab this top image, drag that up to the edge of the image frame. And I can do the same thing with the base. And what I'm going to do is actually going to drag this corner to try to keep the aspect ratio. Try to keep the shape fairly square. So here we are, we've got our frame selected, and now we just go to the green check mark here in Dynamic Crop and hit it. And voila, we have cropped the image, and it's actually rotated it back into a standard frame orientation. And now I'm going to expand that. So that's actually not bad for a cropped image. One very important step I need to do now, though, is save this rotation orientation as well as the size and position of the crop. And the reason I'm doing that is so I can use it to crop subsequent red, green, and blue images similarly. So I'm going to take this triangle in the corner, pull it down, and you see we now have saved our dynamic crop module as a new process module. So if I click in the upper right corner, I can rename this. So I will call it crop. Say OK. And now I'm just going to place it over here with the rest of my icons to be used later. So to make sure that that stays saved, we're going to go to File and Save Project. Say OK. Overwrite yes. And we've now saved the process module, so that crop command has been saved. Now we're ready to move on to our next step. So in our next step, I'd like to model the background of the image and apply that background correction to the entire cropped image. So to do that, we'll use the dynamic background extractor. There is also an automatic background extractor, which is very, very easy. It's a single click. I'm not going to go through that because I think actually the DBE does a much better job. So similarly to what we did in the cropped image, we're going to generate the background adjusted image, but we're going to also save the points that we choose for that background to be applied later to our color images. So before doing any modelization, I'm going to take a quick look at the image and see if I can characterize the gradient in it. And it appears as if we have a brighter background here in the top, especially in the top right corner, which moves from light to dark as we move down the frame in general. So we have a darker gradient at the bottom and a larger or a brighter background here in the top corners. So let me show you why I don't like the automatic background extractor, at least for this image. If you go to Process and go to Background Modelization, we can open up the ABE, Automatic Background Extractor. And the only thing I change on this typically is down here in the target image correction. We can replace the target image with the new modeled image, but I'm not going to do that. I like to generate a separate file. And in the correction, we have two choices, subtraction or division. And typically if I see a light pollution gradient that goes from top to bottom or diagonally, I will use subtraction. If the issue looks as if it's a problem with how the flat frame was corrected in general, I will use division instead. Honestly, when I look at both of them side by side, sometimes it's really, really hard to see the difference between the two. But for our purpose here, we're going to choose subtraction. And now we can just take the triangle and drag it onto the image. And ABE will launch and do its work. And it will generate two output files. Here they are. The first one is the background, which shows you the model itself. So let me just close out of the AB module. And if we take this and screen stretch it and apply a 24-bit correction, you can see the background model that it's generated. And it recognizes, yes, we do have darker field at the bottom, lighter at the top. So it does a very good job of approximating the background model. We're going to close that out. And here's the actual new image with the model applied. We're going to stretch that. And you can see that, yes, it has indeed brightened up the corners down here. And if we look at the extremes, it's done a pretty good job of applying a model to try to get rid of the gradient. But in doing so, it's generated this crazy dark center and what looks like a ring of darkness around the nebulosity. So we can do better. I'm going to minimize this so we can use it later on for comparison. Instead, I'm going to go back to Process, go to Background Modelization and Dynamic Background Extraction instead. And now we've opened up the DBE module. So the big difference is in DBE, we have to actually place the sample points that define what we believe is the background. And this can be really, really tedious and time consuming. But if you do this right, it really makes for a much better background correction. So to start, we just click on our image and we'll get a crosshair. I'm going to leave it pretty much where it is in the center of the image since I've centered the nebula there. And now we need to place our sample points. So what I typically do is I find an area with a lot of stars and noise and something like this here, and I just click on it. And you can see there's a little green box there that indicates the active sample point. And in it we see these dark spots, which have been identified as stars, so they're not going to take part in making a background image. But you can also see that there's been a lot of the background here that's not going to be applied. In fact, if we look at the W sub R here, the weight, only about 62% of the image is being used to correct the background. So what I do is I increase the tolerance to try to get rid of this noise but maintain the stars as being excluded. So we're going to move this value up to 1. And that looks much better. Maybe a little higher, 1.2. So that's not bad. We have a pretty clean background. The stars are excluded. And now we can see that 83% of the background is being used to generate the model. One other thing that we can do is also increase the sample radius. So we'd like to use the largest sample size possible. So if we move this, say, to 60 and say resize all, you can see we're seeing much larger part of the field. The sample box here in the image becomes larger. It's probably not going to work for us because the star density here is so large. It's going to be hard to find a place to put this. Here's one spot, but in which we're not including some of these stars, and we'd like to have as few stars as possible. So I'm going to go back to the sample radius of 40 and resize. The only other change I made is I increased the smoothing factor to 0.5. Since we don't want a model that's going to be generating all of these dark holes, we'd like to smooth it over the larger image, which is what we're trying to correct. So we can increase that smoothing factor. Now, in placing the samples, I can go up here and we place them, in this case, manually. If we want to say hit the generate button, you can see we have the computer automatically place them everywhere in the image. Let me just go to sample color, and what I'm going to do is just change the tone to yellow. There it is, so you can see the sample points more easily. One of the issues here is it places the sample points on nebula here. You can see that the green point selected here is right on the star. So we can move this down, and we could do this to every single sample point and move them off of the stars to an area that they're clear. One thing I'm concerned about, though, is you can see there are a number of sample points where we're not on what looks like clear background, but instead we're on nebula. So it's going to assume that the nebulosity is just a part of the background gradient, and I don't want to do that. So instead, let me just reset this. Once again, we're going to move our tolerance to 1.2. We're going to move our smoothing factor to 0.5 and our default sample radius to 40. And change my colors to yellow. So what I'm going to do is manually place my points. And you don't need that many of them. People place hundreds of these points, spend a lot of time on this. I've done this, and I really don't think I'm getting any better model formation than just placing them by hand. So I'm going to place somewhere between 5 and 10 points in a quadrant. So I'll start here in the lower left. I'm going to find something close to the edge, which looks as if it's background. So there we go. There's 1. There's 2. And what I'm doing is I am avoiding the actual nebulosity so it doesn't alter the model. And I try to go as close to the edges, make sure the edges are covered, as well as the diagonal leading up to the edge of the nebula. Okay, so that's not bad. And I'm also going to go here in the interior. There's a star-free area here. And I'm going to use that as well to define what I believe is background. So I'm going to leave you for a second and complete putting points around the rest of the image. So now you see I've finished placing all of my sample points, staying away from stars and nebulosity. So just as we did with the automatic background extractor, I'm going to say subtract and hit the execute button. And just as we did before, we're first going to see the background model. I'm just going to place this on the side for the moment, and we'll stretch that. And you can see the model is a little bit different. The brightness is now not centered exactly in the middle of the field of view. We see that we're a little bit darker in the lower left. We're darker, but there's a definite difference between the two corners that we didn't see before. So let's see what that did to our image. Stretch that. And you can see we have actually a really nice image. The modelization is much better than we had seen before, and is much more even in the corners of the field. So I can actually compare that here is our earlier ABE image. And if I go back and forth between them, here's ABE and here's the DBE, which is a lot, background is much more evenly distributed. So that's really good. I'm going to discard our old ABE image. And now, once again, very important, we're going to go to the DBE, and I'm going to take the triangle and pull it into the desktop. Go to the right corner and give this a name, which is going to be just DBE. And now we're going to take this and we're going to drag it up to our icons. So later on, when we have a color image, we can use these exact same sample points to correct the background of our color images. Okay, once that's done, I can close out of Dynamic Background Extractor. And what I'm going to do now is save this image. And we're going to save as. And I had a image that I'm going to overwrite, which is luminance underscore CR for crop underscore DBE. So we know what process steps we applied, and say save, replace. And we've now overwritten the image. So if I go to expand this and I put it over our cropped image, we can see what we've actually done. Here's the original image with the gradient in place, and here it is with the background corrected. And you can see this is a substantial improvement in the signal to noise. We get a lot of the faint nebulosity, especially in this area, being pulled out that before was being obscured by the high background levels. And we're ready to move on to our next processing step.
I mag deine Sterne, die